Welcome to Desmos Calculator Bootcamp. Today we will explore scatterplots. So let's start with a really basic scatterplot. If you'll click in any open row, you can click on the plus sign and add a table. So just click table, and then let's put some numbers in. I'm just going to count to, how about 10? And then we'll just put some random numbers here in our Y1. Oops, put too many. Let's go back and put a 0 there. Okay, so here we have a scatter plot. Now, once you enter the numbers into your table, you'll notice in the bottom left corner this little zoom fit pops in. If you'll click on that, it will adjust your window to see your data. So this is really important when the when the numbers in your data set are large and maybe they aren't showing up initially on your screen. That little plus will put the points right in your sight so you can see them well. You can still continue to adjust it to make it look even better if you would like. Now this data we would say has a negative correlation because as the independent quantity is increasing, the dependent quantity is decreasing. Now let's add some detail to this graph by clicking on the wrench. I'm going to label the x-axis with an X, y-axis with a Y, and I kind of like everything else. I'm going to leave that alone for now. So this looks pretty good. Now it looks as though this data may have a linear correlation. So what I'm going to do is I'm going to type Y1, which stands for the variable at the top of the right column in our table, and then I'm going to type tilde. Now the tilde is right below the escape button on your computer if you're wondering where that is. And then we're going to type M, and that stands for slope, and then we're going to type X1. Now that stands for the numbers that are under in the left column of this table, and then we're going to type plus B. So you may recognize this is really Y equals MX plus B, and we're using X1, Y1 for our order pairs in this data, and we're using the tilde instead of the equal because that's indicating it's a regression equation. And you'll notice that it has created a line and it has put that line into this graph. Now down here is some data that we're given about this line. We're told the slope of the line is about -1/2, -0.5333. The y-intercept is 6.1333, which is right here. We're told that the correlation coefficient, that's the lowercase r, is -0.8357. That's telling you that this is a pretty strong correlation because it's close to -1. -1 is a perfect fit. It also tells you that the data is decreasing. Now here to the right of that is this E1, and this stands for your residual. The E stands for error. So click on plot and it will plot your residual, and it will create an extra column in the table, and it will label that E1. So this is the error in the data, and you'll notice these numbers are pretty small, which is good. It means the data is reasonably well fitted to this line. And the closer these numbers are to 0, the better the fit. So we have a pretty good idea here. You can turn off your data from your original equation. Click this little spot here and it'll just show the residuals. You can turn that back on by clicking on that circle, and then I'm going to turn off the residuals and I just see the data. So, or you can leave them both on there. So however you want to do it. This is the most basic fundamental part of looking at two variable data in the Desmos calculator, but there's way more. Let me show you something very cool. We're going to use data that's in a Google Sheets. So here I have some data that I just basically grabbed from a website, boxofficemojo.com. I've already kind of cleaned it up and included only the stuff that I care about, and I actually am using this particular data in one of my Algebra 1 lessons, but I want to show you how amazingly easy it is to take data from a Google Sheets document and then paste it into Desmos. So what I'm going to do is I would like to use the year, and I would like to use the number of releases. So that would be column C. So the way that I do that is I highlight column A, I hold the control button and then I highlight column C. And you'll see both of those columns are highlighted, and there's quite a bit of data in those columns. Now to copy that, I simply type Control C. Now I am working on a Windows machine. There are slightly different commands on your Macintosh, or if you're using some Apple product. And then we're going to go back to our calculator. Now I've cleared this out and started with a blank graph, and then what I'm going to do is I'm just going to click on a row here and type Control V or paste, and it will paste that data. And the beauty of this is it automatically zoom fits your data. So your window is already adjusted to fit the data that you're seeing here. And so here I see data, and these are the years down at the bottom. It's so easy to read. You may notice there are 33 more rows. Those rows are hidden. If you click here, it will show those rows. And when you click off, they will again be hidden, mainly because it gets so long that it kind of pushes all the other stuff that you're doing in your calculator off the screen. So they do shrink that down, and that's so nice. So what I would like to do is do a linear regression for this data, but let me show you something very cool. This is a brand new feature. I have not seen it until just recently, but I wanted to show you. I don't know if you noticed this here, it says add regression. So this is a new feature in the Desmos Calculator. Click there, and then it will add a linear regression by default. Now what's cool is there's all these other types of regression. So let's say that I don't really believe this is linear regression. Maybe this is an exponential regression. So we could try that and see if that looks better, or a quadratic regression. So what it will do is it will fit the data to this function to this data, and then you can kind of take a look. I'm guessing linear is probably our best bet here, but you may notice that some interesting things are happening right around the year 2020. Now I wonder what that might have been. What happened to movies in the year 2020? What do you suppose explains that sudden drop? I'm not going to tell you, but I think most of you already have an idea what that might be. We're doing an exploration of that data in our Algebra 1 curriculum. If you want to go take a look at that lesson, I've already got one made up for this. But this is some of the cool features. You don't have to type in anything. You can just click regression. It's going to give you that linear regression. Now this is y equals mx plus b. It's giving you the equation. You can copy that equation and see how it pastes that into, and now I've got the actual equation. I can delete this and I can work with that equation. Or maybe I really don't want 17.79612. Maybe I'd rather just have 17.8, so I could round that, and maybe I don't want all these digits. I could round this to 33. So these are or just 3. This is the number of movies that would have been released. Because remember, the data that I chose here was the year and the number of movies released. Now let's put those labels on here. If we're going to use this in a class, we would like to know what this stuff represents. So this X was the year, and the Y was the number of movies released. Now another thing we can do with our scatter plots that we're creating and our regression equations that we're putting with those is we can export this image and place it in some other application. So often my students will use Google Slides or Google Docs, and we want a nice graph in there to talk about as part of our work. So I would click on this share button and then export image, and then I have lots of choices here. I can do a medium square, a large square. I can change the thickness of the lines. I think I'm going to stick with medium and do medium. That looks pretty good. Or maybe thin makes more sense. Now you can download PNG. That will download it to the device that you're on, and then you can upload that into your application. But for most students, they simply click right here on this graph and copy image, and it will paste that image from their clipboard directly into the application that they're using. So I would say for my students, they kind of prefer to copy paste it right there. Works pretty well. Now, one thing I did want to point out with these 3 dots, when you click on this, it's going to give you a little more specificity as to what it's doing. The regression model structure is given y tilde mx plus b, and of course it's using x1, y1 for the 2 columns. But let me just show you something else that you may find interesting. Let's say we would like to do a regression model, but we're going to delete the last few years of data because, well, as you can see, these numbers are significantly lower than the rest. So I'm going to go ahead and delete the year 2020, 21, 22, and 23. And so here I have my data. And what I would like to do is create my own regression equation. I'm going to back up a little bit in here. So let's back up. It'll show the last 4 years in the table. I would like to do an exponential regression equation. I'll do the standard one to show you what that looks like. I'm doing this manually without their new feature. y1 tilde ab to the x. Okay, so we need a 1 on that, sorry. All right, now I have a pretty good model, but let's say I would really like to move my function up in the plane. So instead of just ab to the x, I want to translate it up with a plus c. So I'm going to put a plus c in there and see if that makes a difference. And do you see what it just did? It put a minus 1,460 there for that c, and it does fit way better with that added parameter to my equation. So what I'm saying is the regression equation that you're given by default may not be the one you prefer, so you can play with it and add additional, different things that you would like to do. And for exponentials, from my experience, the one I'd like to move up and down in the plane, I usually want to do this, and it's so cool that Desmos allows that. I don't see that functionality in other types of calculators, or at least if it's there, I don't know how to use it because I've not been able to do that with the other handheld models of calculators. So I just really love the fact that I can not just use your standard a times b to the x power, which is your standard exponential regression, but I can even translate that up and down with plus c. You can go even further. If you would like to translate it left and right, you can add or subtract like a d to your exponent, x1, and that works too. You can do that as well. So there's really no limit to the way you want to handle these regression equations. You can put them in all different types of forms, which I think is really exciting. One last thing I wanted to point out before we close out this video is that if you do click on these points in the graph, you can see the actual data that was graphed. Since that's already over here, it's not going to give you the option of exporting those because you already have all these data points in the table. So you can do that. Another thing you can do is you can click and drag on this actual function. And once again, if you want to do your residuals, click on the E subscript 1. And there's the residuals. Now, unfortunately, my residuals are the same color. That's not good. So I'm going to come over here and click and hold. And I'm going to change that to red. So my residuals are in red. And now you can kind of see how the numbers are above the 0. Then they're below. Then they're way above. Then they dip down. So we do have a little bit of variability in our data. These are great things to talk about or discuss. Why were there more movies released in this period between 2000 and 2010, and why were there maybe fewer released? The numbers are a little lower than you would expect between 90 and 2000. That would be a fun conversation to have about these data. That's all I've got for the 2 variable data, but there's lots more features in here. I've kind of just given you a little taste. So please go to Desmos.com, open a graphing calculator, get in there and play. You can go look for some data online. That's what I did to find my movie data. Copy and paste it directly into Desmos without having to type. Just see what's possible. It's very exciting. It's a great way to get your mind wrapped around the data that you encounter in your classes. Y'all have a great day.